Today's notes are on factoring a difference of two squares. So this is a little special factorization. So if you can recognize that something is a polynomial is a difference of two squares, it could save you some time. So first thing we're going to do is take a look at this multiplication problem. Right here we have a plus b times a minus b. And if you remember, we looked at a similar case of this when we were multiplying polynomials. So you can actually multiply this out using a box, and we can set up a plus b along the top and a minus b along the side. We get a squared, ab, negative ab, and negative b squared. And when we add all this up, what's going to happen is these middle two terms of the ab and the negative b or negative ab are just going to cancel each other out. So our completed multiplied standard form would be a squared minus b squared. Okay, so we see this general relationship where anytime you start with a plus b times a minus b, so the same things added and then subtracted being multiplied, you will always end up with a squared minus b squared. And this is going to work to our advantage when we try to factor. So when it comes to factoring a difference of two squares, the general rule is if you see a polynomial that's of the form a squared minus b squared, so one thing squared minus another thing squared, and the difference is important, that's subtraction, right? So you're looking for a subtraction or a difference polynomial. So a squared minus b squared will always factor into a plus b times a minus b. So we're going to take a quick look at some examples, and I think you'll find they factor pretty quickly. So the first example is x squared minus 49. And so again, we're trying to recognize this as a difference of two things being squared. So we can kind of think about what is being squared to give us our term of x squared. Well, x is being squared, right? So we can kind of think of it as what is being squared then to give us 49. 7 is being squared. So this helps us identify what is a and b in terms of the a and b in this form. And then we know how to factor. We know this must be the first thing plus the second thing times the first thing minus the second thing. So that would give us x, well, let me try to write that again. X minus 7 times x plus 7. And the order here doesn't matter, so I could also have written x plus 7 first and then x minus 7. My next example is 5x squared minus 64. So again, we're thinking, what can we square to give us each of these terms? So for 64, hopefully it's obvious that it's going to be 8. But we run into a problem with the 5x squared because there's no whole number that I can square that will give me 5. Right? So there's nothing we can think of that could work for that coefficient. So therefore this is not a difference of two squares. And if it's not a difference of two squares, there's nothing more we can really do here. So we're just going to stop. We give up. Looking at the next example, you might think, oh, here we have x being squared to give us x squared, and 6 being squared to give us 36, but you need to be careful because there's something wrong here. And the key thing is that this is an addition problem. You have x squared plus 36. So this is also not a difference of two squares. And we can't do anything else here either. One last example for you. We have 16x squared minus 1. So once again, we're thinking what squared gives us each of these two terms. So to get 16x squared, well, I know there needs to be an x in here to get me the x squared. And then what squared is 16? 4. Now to get 1, that's simple. It's just 1 squared. So now I know my factored form should be 4x plus 1 times 4x minus 1. So now I have two problems for you guys to try, so you can just write these solutions at the bottom of your notes, and we can discuss any questions you may have in class.